Hello everybody, my name is Dr. Gulshan Murgai. I'm a general dentist based just north of London in England, and I'm here to speak to you about our innovative clinical solutions from exocad. And what we're calling this presentation is Innovative Clinical Solutions from Design to Manufacture. And I'm going to take you through a whole number of steps. So we're talking here today about innovative clinical solutions, and we're going to look at two different parts of software, two different software platforms, both from the exocad company. exocad is very well known for its 10-year history in providing laboratory-based software for computer-aided design and manufacture. And what we're going to look at is products that have been released by the exocad company in the last few years that enable clinical innovations. So I need to give you full disclosure. I am a key opinion leader for Vita, for exocad, and also for Medit. My company is also a reseller for NT Trading products, for exocad products themselves, as well as Sealodent, Envision Tech, and Woodpecker. So that's where I'm coming from. I am a general dentist. I'm part of what I describe as an extended dental team. And my extended dental team, and I hope yours too, involves my front of house staff, my receptionist, my practice manager. We're including dentists that are specialists as well as general dentists. I myself love the fact that I'm a general dentist and not specialist. Certainly we include dental nurses, sometimes known as dental surgery assistants, hygienist therapists, dental technicians are absolute must to be involved in this process, as well as now clinical dental technicians as well. So that is what we are talking about with respect to the extended dental team worldwide. Now let's look at exocad and the 2 out of their 3 product platforms that we are looking at. We're going to look at today chairside design, so that's ChairsideCAD, and we're also going to look at exoplan. Exoplan is the implant planning and surgical guide design software, and we're going to look at both of those today. We're going to start by looking at and discussing ChairsideCAD. ChairsideCAD is one of exocad's softwares that's 2 years old. I've been using it right from the start, and prior to that I was involved at exocad with their laboratory software, as I am actually a laboratory owner as well as a general dentist. So one of the benefits of ChairsideCAD as a software package is in its fabrication, in its construction. exocad spoke with material producers, intraoral scanner producers, dental labs, 3D printer manufacturers, desktop scanner manufacturers, because exocad is famous for creating open platform software. And so that they created an open platform that is accessible to the many and not the few, they have really collaborated well with all of these different people. The structure of ChairsideCAD, as well as what we're going to talk about shortly, which is exoplan. Exoplan and ChairsideCAD both have a modular structure. Now, the modules available with ChairsideCAD are significantly more because it enables you to do a lot more. So there are implant modules, there are DICOM viewers, there is your base module that allows you to create inlays, onlays, veneers, crowns, bridges. There's also what's called a smile creator module for the fabrication of anterior smile design, multiple unit cases. It allows you to create bite splints as well as 3D printable models. So significant amount of modules available that you would speak to your reseller about and say, well, I need this, and you only purchase what you require for your needs. Clinical uses are several, as it says here on the list: inlays, onlays, anterior and posterior crowns, bridges, veneers, splints, and we're talking about printable hard splints here. Implant restoration is very popular with my clients. Smile design, planning and fabrication, and something that's really well integrated is DICOM integration. So with more and more people having bought in-house CBCT scanners because of their price coming down, it's important when you're planning implant restorations to be able to collaborate all of your data together from intraoral scanning as well as X-ray as well. So I'm going to just show you some examples of what type of restorations can be made with the ChairsideCAD software. And we're looking here on the left-hand side at a full arch restoration. So you could design, and if you had an appropriate mill, you can manufacture that. You can see on the right-hand side there are multiple crowns there. we've now got here up on the screen, you can see a implant planned case where a patient has been scanned with scan bodies, and then you can design a screw retained or cemented restoration. Now, I've already mentioned that exocad is an open platform, and here you can see a host of different intraoral scanners, and all of these intraoral scanners can produce an open STL file. Now, as long as you can generate an open STL file, you can use exocad for ChairsideCAD design. So you can see here scanners from Plan Mecca, from Sirona, Carestream, 3Shape, AlignTech Itero, and of course Medit as well. Now moving forwards, you have the option, when you have the capability to do design using ChairsideCAD, you have the option of whether or not you want to invest further into manufacture as well. So some people will invest first in stages, so they'll buy their intraoral scanner. Later on, they'll say, well, I'm happy with my scanning protocol now, I'd like to start getting involved in design, and they may still be collaborating with a lab or a milling center for fabrication, or they can go the whole hog and they can purchase 3D printing, they can purchase milling as well. So we have a platform within ChairsideCAD called Dental Share, where the reseller would invite the end user to be able to use that platform and very quickly and easily share their design and their workflows with colleagues, with other members of the Dental Share platform, as well as laboratories. Now, if you're going to get involved in the manufacture, then exocad has a nesting module. On the left-hand side, you can see there a nesting of a restoration that you could cut chairside with one of a host of 6 different milling machines. So that's nesting a restoration into a block, which could be of a variety of materials. On the right-hand side, you can see nesting in a much bigger structure. So that's your classic disc or puck that would go in a 5-axis milling machine, and really depends on the workflow that the practitioner or the group of practitioners are looking for as to whether they go to block milling or disc milling, or perhaps both. Here you can see on the screen just a whole host of different materials that are available right now. In the middle of the section are what I would consider to be the most innovative. These are mainly hybrid materials, but all of these different materials here that you see are blocks that are available for different machines. There are a combination of lithium silicates, lithium disilicates. We have their PMMA, we have feldspathics, a whole host of different restorations, including your very well-known brands there. And you will find that most of the big international brands are creating substrates of this type for chairside restorations, because it's becoming more and more popular worldwide, especially now that it's something which is open architecture. Now, I personally do a lot of work with Vita. I've been using Vita's products for around about 16 years now. And here on the screen, you can see a number of their products. Inamic is their flagship product. But I also am using Vita Mark II, which is a feldspathic. They have their PMMA, which is a reinforced PMMA for long-term temporary restorations, and then Suprinity, which is a zirconia reinforced material. Now, as I said, Inamic is a very special material because it's a hybrid. Hybrids are becoming very popular with the manufacturers. So GC has one, 3M has one, Vita has one. Vita's product is called Inamic. It was the first of this type of product available. And it's a material which, because of its mix between porcelain and resin, it can absorb occlusal forces. It's great in cases of bruxism. You can use it for a screw retained restoration on an implant, as well as on teeth as well. So it's a strong material. It has the aesthetic properties of a ceramic. It's polishable. It can be glazed, not necessarily in a furnace, but certainly you can paint on a glaze. So it's very, very easy for chairside manufacture. It's also available now in a polychromatic. So the polychromatic block, as you can see here on the screen, has a fantastic 6 shades going through it. Now, I think there will be very few technicians that would agree to be able to put 6 different differentiations of shade in a single restoration. Well, now practitioners can do this in a chairside type of restoration. So there's no problem, I think, now in doing anterior restorations with chairside structures so that you can create beautiful looking smiles. And the benefit of this for me is that if I do a single anterior, or let's say I do 6 anteriors, and the patient has a problem sometime later on and you need to remill or reproduce something, if that was a hand-built ceramic made in a laboratory, chances are that I would say to that patient, well, I'm afraid whilst you've broken one, I'm going to suggest replacing 2 so that we have symmetry. Here, with digital restorations made out of polychromatic structures, your restoration design would be saved. And actually what you can do is just go ahead and pick up the same matching block, put it in your milling machine, push a button, and design and mill exactly the same restoration again to replace it without the patient having extra time, cost, and risk of replacing multiple restorations. So I certainly do appreciate the talent of laboratory technicians, and certainly there's a massive place in my daily work for labs and laboratory technicians. But what I'm trying to say here is that with the invention of multiple polychromatic materials, you can do anterior restoration successfully. VitaCAD Temp, I already touched on. That's a reinforced PMMA. Again, that's available in monochrome and multicolor. Now let's move forward into manufacture. ChairsideCAD as a software product can be linked up with a variety of different mills. There are specific milling machine manufacturers that exocad has worked with. So on the left there is the VHF machine. In the next one along is the Roland, then there's the IMS iCore, and the one on the far right hand side is one of the iterations of the Armin Gerbach machine, which actually is the Carestream version there. It's also available from Straumann and Armin Gerbach themselves. So 6 different machines available, 4 of them are on the screen there, all nicely linked up with ChairsideCAD in such a way that you can push a button at the end of your design and push the restoration straight to the mill. Also, they've worked with 3D printing manufacturers, so you can see NextDent's product there, you can see SprintRay's product, EnvisionTech, and also Asiga. All of these are machines that work well with the exocad platform. I'm going to now show you some of my real-life cases that I've made with the current version of ChairsideCAD, ChairsideCAD 2.3 Matera. Now, each different version of exocad software that comes out is named after a city. So currently we're working with the Matera version. So this is a case here that I did last year. And you can see this is upper left, 2 molars. So one had a crown, one had an onlay. You can see the color scan that I've taken. You can see the data when it's gone into exocad. Here you can see different views as to what I've done in terms of the design. You can see from the occlusal view. And in the bottom right-hand side, you can see an image where you can see the Fisher pattern in what we call the True Smile color. So True Smile is one of the modules that's available with ChairsideCAD, and it's to enable the practitioner and also the patient to see what that restoration would look like in tooth color. What's interesting is you can even show them what it may look like in gold or a non-precious metal. So if they really are toying with whether they can afford or should go for a ceramic restoration as opposed to a metal, you can actually show them in real time what that might look like. Here again is one of my cases, an endodontic complex case, which if you look at the bottom left-hand image, a lot of practitioners might say, I'm afraid that cannot be saved. We've been able over the years, I've been doing this 16 years now, ChairsideCAD, with different systems, I've been able to really push the boundaries. So a case like this, I've done an endodontic treatment, I've left the site to heal for a few weeks, got the patient back in, scanned, designed and manufactured at the same time. This particular patient had 3 restorations done in a single visit. The root treatments were done separately though. So here you can see I am really trying to highlight different methods of tissue retraction. People are often worried about doing subgingival margins with digital, especially deep margins. Well, the top right-hand image, that is a preparation that is 3 millimeter subgingival. Now, the bottom middle image, you can see exactly the same tooth preparation, and you can see that with various techniques, whether it be chemical or physical or laser, we can manage soft tissue, and therefore, if we can manage it, we can usually image it. Same case that I showed earlier with the x-rays. This is the patient having had her endodontic treatment. Again, very deep subgingival in the lower jaw. She had a gold crown that we replaced for a full ceramic. We left the gold core. And the third restoration, all the same patient, is again deep preparation, endodontics done, and you can see there I'm managing the tissues with retraction cord. Same case here. This is the monochrome images of the actual scan brought in from exocad, and you can see I've overlaid the design in both monochrome as well as in true smile colors. And that's the case in color. Another different case here, I do a lot of posterior work with ChairsideCAD. So here again, a quadrant, so we've got a 6 and a 7 again. This time the crown is on the 6, the onlay is on the 7, again a root treated restoration. And a similar type of workflow whereby we've done the endodontics, left it to heal, manage the soft tissues in the interim, and then we go back and scan, design, manufacture, and fit in the same visit. So again, another quadrant. Okay, so now we have finished speaking about ChairsideCAD, and I'd like to speak to you about exoplan. Exoplan was released at the Insights meeting in Darmstadt in 2018, and I was very proud to be there and see the launch of this new product. Exoplan is exocad's platform whereby it allows users to not only plan their implant placements, but also then if you have the adequate module, you can then design a 3D printed guide for the surgery. Now, we call this predictable implant surgery, and let me guide you through and show you how we do this. So all of the different exocad software platforms come in 2 split versions. So here we have exoplan DB and we have exoplan the design software. So DB in each instance stands for database. It's very important that exocad knows what you're trying to do with the software and also what level of information you're going to give it. So whether it's a single arch, whether it's upper and lower, whether you're putting in pre-op scans, whether it's a single or a multiple restoration. It's also where you designate whether the restoration will be screw retained, cement retained, custom abutment. So a whole host of different options are available. And in the DB element is where you would tell exocad or exoplan here what you are expecting from it. Once you've programmed that software, which just takes a few minutes, you then jump straight into the design element and the planning element. So we're going to go through that. Now, I've used a whole host of different planning softwares over the years. I've got software that comes with my CT scanner. I've used a whole host of different, perhaps you could call them competitive softwares. And whilst my opinion is biased, I do use exoplan each and every day, whether I'm doing a single unit, whether I'm doing a clearance, a full arch, multiple units across the arch. And I'm going to show you some of my real life cases. One of the best things about exoplan is its high accuracy in the alignment of scan data. Now, what we're talking about there is 2 different sets of data. The accuracy of your implant placement and planning, and also therefore the accuracy of your 3D guide and how well it fits in the clinical situation, all really depends on the quality of the data that you bring into exoplan. So when we're teaching new users, we are talking to them about what type of impressions they should take, what type of materials they should use. If they're using intraoral scanners, it's about how to capture the difficult areas. And then moreover, it's about how to then go to your CT scanner and how you might want to manipulate the way that you take that CT scan image. So CBCT most of the time these days. And the benefit of exoplan as a software package is how accurately and easily you can relate the CBCT X-ray data on top of or alongside the intraoral data. And I'm going to show you how we do that, okay? Once that's done and you've gone through the whole pathway, the workflow, so to speak, of planning your implant placements and then designing your guide structure, there is obviously the possibility of either producing this in-house if you have 3D printing facilities, or you can, of course, have that made at an external facility. It's totally up to the individual as to how far they want to invest. And again, this is one of the positives of the exocad software packages. because they're modular. You're not forced to buy anything that you feel that you don't want to get into unless you're ready to do so. Now let's look at the stages that are involved. So the first thing right at the top of the diagram that you can see there is taking a CBCT. Also collaborate that with, or combine that with potentially an optical scan. That then comes to the dentist, the surgeon, and also to the laboratory. Now, there should be some collaboration there. There are two different ways that exoplan works. There's either the laboratory doing all of the work, so the dentist basically hands everything, all of the data set to the laboratory, they do the planning and request approval of that planning from the dentist, or the dentist can have all of it, or there can be a collaboration. So there's three different ways of looking at this. So collaboration means that perhaps the dentist does the planning and then they hand over that approved plan to the laboratory and ask them to both design and manufacture the guide. So it's very much a modular and collaborative process, and that's why I've highlighted who is part of what I consider to be the extended dental team. So once there is approval from the implant planning stage, that goes forward so that the guide can be designed. Once the guide is designed, there has to be some decision as to whether that guide is going to be for pilot drilling or whether it's going to be for fully guided. And of course, there'll be some collaboration with the lab to actually say, this is what level of surgery I would like to do with this guide. And then it's about production, whether that's a milled structure, whether it's a printed structure, whether it's outsourced or whether it's done in-house. So that pathway guide there really gives you so many different ways of going left and right and through the process so that you get something that works for both your level of knowledge and also your level of really how much time and effort and money you want to put into this at the start. Let's look at the steps graphically now. So on the left-hand side, this is one of the first stages that you will see in exoplan. It's asking for data, and on that particular screen, the software is asking for where is the location of the CBCT data. On the right-hand side, the data sets have been brought in, and on the left-hand side of that particular image, you can see the CBCT data. That is obviously the rendered data, so you can see the full skull, you can see the teeth there. And using the software, you can remove certain elements so that you can just see bone, or you can see bone and tooth. On the right-hand side of that split image, you can see the intraoral data. Now, in that particular case, that was an impression that would have been cast by a model and then scanned with a tabletop type of scanner. And then all of the data is brought together in one place. Now, on this next screen, you can see two sets of images. On the left-hand side, the image is the correlation of two sets of data. So this is the really, really important part about accuracy. If you can get that level of correlation, which is shown graphically with the colors on the screen, the blue meaning absolutely minimal deviation between the two sets of data, then you know that you can rely on this software package and what it produces as being highly accurate. And really, it's all about safety for your patient, because that's what we're here for. We're actually here to provide innovative clinical solutions really for our patients. So that image is showing the level of accuracy of correlation. On the right-hand side there, you can see that you have some CBCT data that exoplan has been able to extract an OPT out of. So a 2D image has been extracted from the 3D set of data, and that really just makes planning at the later stages much easier. Now, exoplan is a way, it's a software package that allows you a way to restoratively plan implant placement. And what that means is that for a long time, many people have been placing implants, and there have been lots of different trends. I wouldn't say it's a current trend. I think it's going to be a long-term trend that, given that people don't want screws, they want teeth, it's important that we can look at an end goal and engineer backwards from there. And that's what this platform is all about. This part of the software gives you the ability to say, okay, where would you like to place the teeth? okay, because that's what our patient wants. Let's place our teeth in a way that works functionally and aesthetically. So the left-hand image there is the option and the availability to plan the final position of the restorations. The right-hand image is now taking that data set plus the CBCT extra data set plus the data set from either taking an impression or a scan of the patient. So there are now 3 sets of data all overlaid on that right-hand side, and that's why it looks quite busy on that screen. What's happened there is on that right-hand side screen, the practitioner or the person that's been creating this plan here has chosen from a big long list of implants available in the library to say, this is the implant that I'd like to place. And what they've done is they're placing it in 2D on the OPT, in 3D on the middle screen there using the CBCT data, and then they've also got cross-sectional data as well. So it's a very quick, easy way to place an implant and then have the ability to manipulate that. And you see that on the next screen here. On this screen, you can see that we're looking at specifically one implant. You can see the color, the red, blue there shows as bone density. So you can use the exoplan software to give you a graphical way of knowing that your implant is actually nicely surrounded by bone. Now, if it's low density bone, you get the warning. You know that, okay, you can place this implant, but you might need to manipulate the bone differently during surgery because of the low density nature of the bone. The final screen there on the right-hand side shows the restorations. It shows the implants relative to the scan data from intraoral as well as the CBCT data. So it's a nice tidy way of bringing it all together. And finally, what the software will generate is a report. So you can see that PDF report is on the left-hand side. Now that's brilliant for compliance. In the current day and age that we live in, it's really important to record our planning, to be able to bring that into our patient record and show that, look, I did actually plan your case in intricate detail and here is the planning. Now, if the dentist was just doing the planning, that would be the end of their role. At that point, they would package that data set and hand it over to the laboratory. So that was exoplan implant planning. The next stages from here are part of what's called the guide creator module. So the kind of middle step in between is this step that I'm going to show you on the right-hand side screen there, and that is the positioning of the sleeve. The sleeve is still the responsibility of the person that is planning the implant positioning. And that's because the positioning of the sleeve is designated by the drill set that the surgeon is using. So if the drill set is from a specific surgical set, you can actually position that sleeve so that when the technician designs the guide and you use that guide, that when you make that primary osteotomy, that you're drilling to full depth. Okay, so you're not getting a half depth or part depth. You can position it in such a way that if you use the right type of drill, you're drilling to full safe depth. So that's very important, and that's the role of the practitioner. That's the final part of their role. Moving forwards now, once that has been done, that sleeve has been positioned, you get to start designing the guide, and these are quite straightforward steps. So here the software has put what are called sleeve mounts onto the structure. So the X-ray data has now gone. On the right-hand side, you can see a partially designed guide. The red cylinders that are there are a protected area. It means you can't change anything or manipulate anything in that area, because that is the path of insertion of the handpiece, so that the practitioner can bring the handpiece along and know that there's nothing in the way of the surgical path, so to speak. Finally, once you've designed a guide, whether it be a sectional guide, a full arch guide, as you see here, you get the opportunity to place windows, you get the opportunity to place structures and elements to ensure that you have a solid structural prosthesis. And on the right-hand side there, you see the finished article, which again is an image that can be saved in the patient's record or can be kept just for collaboration with your colleagues, maybe in the lab. So you see on the right-hand side that we have a full arch guide here being used to plan the positioning of 2 upper central implants, and you have windows all the way around that guide so that you can ensure adequate and full seating of the guide when it's in the mouth. Once again, once you get to that end stage, exoplan gives you a protocol which is printable and certainly can be exported and brought into the patient's record, and that carries a lot of data there as well, so compliance being a very important step. Finally, just coming towards the end now, this is one of my cases. This is me just showing you that if you're doing multiple implants next to each other and you're trying to purposefully make them parallel, the software will tell you the angles between the implants so that you can ensure that they're as parallel as possible, either for linked crowns or for bridge work. Here's another one of my cases. This is a mandibular case, and you can see how from the CBCT data, exoplan was able to pull out data to produce an OPT, a two-dimensional image. On that image, it has then overlaid my mandibular nerves on both sides. It has overlaid my implant positioning and also my sleeve positioning. So really important way of easily collaborating with other colleagues to say, hey, this is my plan, what do you think? Going on from that, this is exactly the same case. And what I want to show you here is that whilst you can graphically plan these type of cases very straightforward, very easily, using a structure, using a process, in the background, the software is working quite hard to create detailed reports like this. On the left-hand side is the surgical protocol. And again, I'm showing you this because this is a multiple implant case. So it's giving you a protocol so you know what to order for that particular patient in terms of diameter and length of implant. Also, you can see in the bottom half of that PDF, you can see the positioning of the sleeve relative to the implant, and you will then know what is the pilot drill that you would need to use for that particular case for safe drilling. Finally, on the right-hand side, you can see that we have cross sections of the original CBCT data. So you can clearly show to any colleagues or the patient themselves that you've gone through intricate planning, and the planning was based on a restorative guide. So you've said, here's where I want your tooth to be. We're agreed in that in terms of aesthetics and function. And from that basis, I'm reverse engineering the positioning of the implant. Thank you very much for listening. I hope what we've gone through with you today has been useful, and I hope that if you have any questions, you will feel free to contact me. Here are my different ways of being contacted. I'm available on social media, also directly. You can email me as well. My name's Gulshan Mergai. I'm from Implant Solutions Direct in the UK. Thank you very much for listening.